Okay, so today we'll solve GET 2022 questions. This is a question from algebra. It is question number 37. So it is saying that let two proper non-zero ideals J1 and J2 of non-zero commutative ring are given. Proposition P is saying that for any R1 and R2 in R, there exists a unique R in R such that R minus R1 is in J1 and R minus R2 is in J2, and Q is saying that J1 plus J2 is R. Then which of the following statements is true? P implies Q or Q does not imply P, Q implies P or P does not imply Q, P implies Q, Q implies P, or P does not imply Q, Q does not imply P. Okay, in order to solving this is the NPTEL reference. Okay, so let's see. So first P, it is saying that for any R1 and R2 belongs to R, there exists unique R in R such that R minus R1 is in J1 and R minus R2 is in J2, and Q is, so what is this option is saying? This option is saying basically if you take this map R to R mod J1 cross R mod J2, so saying that this map is injective and surjective, right? Because surjectivity is saying that for any R1 and R2, so any R1 and R2, R minus R1 is in J1 minus this coset, R goes to this R bar comma R bar. So this is saying that surjectivity means for take any R1 and R2, so R minus R1 is in J1 means this is the class, equivalence class. So if you take any element from R mod J1 and R mod J2, then you will find an R such that R minus R1 is in J1, R minus R2 is J2. And unique, it is saying that this map is injective, means it has kernel to be 0. Because if it has some non-trivial kernel, then that element J1 and J2 intersection is non-zero, then this map will not be certainly not injective, right? So this is a P is saying, and Q what is? It is saying that J1 plus J2 is R. So this will say, these are saying that J1 and J2 are co-maximal. This is called J1 and J2 are co-maximal. Okay, so first we'll show that P implies Q. So let's do this. P implies Q. So we have to prove that J1 and J2 are co-maximal, means J1 plus J2 is R. So suppose not. Suppose J1 plus J2 is not equals to R, which implies let A is in R such that A does not belongs to J1 plus J2. Now we will choose these two elements. So choose R1 equals to A and R2 equals to 0. So what this P is saying that for any R1 and R2, you will find a unique R such that R minus R1 is in J1, R minus R2 is in J2. So let's apply this. So then by P there exists unique R in R such that R minus R1, which is basically R minus A, is in J1, and R minus R2, which is R minus 0, is basically R, is in J2. So R minus A is in J1 means A minus R is also in J1 and R is in J2. So if you add these two, which implies A belongs to, which is A minus R plus R, so it belongs to J1 plus J2. So we start with AR, which is not in J1 plus J2, but we have end up with, so that A is in J1 plus J2, so which is a contradiction. Means, so therefore J1 and J2 are co-maximal. J1 plus J2 is R. Okay, so you've got P implies Q. Now we will show that this Q does not imply P. Means for, if it is co-maximal, then for R1 and R2 we will not find a unique R, we may not get a unique R, so that this will happen, right? So Q does not imply P. Counter example. Okay, so you have to find out the counter example, so that J1 plus J2 is co-maximal, but the P is not. So what will be the counter example? Take R to be the ring Z and J1 to be the ring 2Z and J2 to be the ring 3Z, right? So then this is the map, right? Z goes to Z mod 2Z cross Z mod 3Z. Now first note that J1 and J2 are co-maximal. Note that J1 and J2 are co-maximal. Why? Means 2Z plus 3Z is Z, right? Because as GCD of 2, 3 is 1, so which implies there exist m and n integers such that 2m plus 3n equals to 1, which implies that 2z plus 3z is z, right? So therefore J1 and J2 are co-maximal. Now I will show that if you pick some element from to ring R1 and R2, then there does not exist a unique element which such that R minus R1 and R minus R2 is in J1 and J2. So take this two. So this is the map. Z goes to Z mod 2Z cross Z mod 3Z. Note what is the intersection. So we have to find out which is in the kernel, right, of 2Z. So 2Z intersection 3Z, this is 6Z. So take R1 also 1 and R2 to be 1. Then R equals to, if you take 1 plus 6m, where m is an integer, and then for r minus r1, which is basically 1 plus 6m minus 1, which is 6m. So this is the 0 element in, right, r minus r1, this is in j1, right, j1 is the 2z, and r minus r2, 1 plus 6m minus 1, this is again 6m, which is in j2, which is 3z, right. So for r1 and r2 you have find this r which is not unique, right, because it is 1 plus 6m. So therefore there does not exist unique r in R such that r minus r1 is in j1 and r minus r2 is in j2. So Q does not imply P. Okay, so therefore option number A is correct. P implies Q, but Q does not imply P. Okay.